Hello everyone. Welcome back to Dr. Lou's VCE Science channel. Today, let's learn together about the 2023 chemistry exam in the Northern Hemisphere. We will focus on multiple choice questions related to reaction heat, chemical equilibrium, and reaction rates. My explanations may not be perfect. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. This question's keyword is combustion. Any combustion process requires oxygen and is an exothermic reaction. Therefore, only option B is correct. This question is related to chemical reaction equilibrium, testing students' ability to interpret graphs. In the graph on the right, we see that two decreasing lines indicate two reactants and one increasing line indicates one product. Therefore, options A and D are automatically ruled out. The remaining options are B and C. The ratio of the two decreasing lines is the same, and the increasing line is twice the magnitude of the decreasing lines. Therefore, B is the correct answer. The keyword is bioethanol, and bioethanol can only be derived from biological processes. D involves a chemical process. The product of C is biodiesel. Although B can produce bioethanol, it is not on an industrial scale. Only A, fermentation, can industrialize the production of bioethanol. This question revolves around understanding the experimental process. Placing the reaction system on an electronic balance, the balance reading continuously decreases, and after 10 seconds, it stops. The volume of the reaction system remains unchanged. The first part indicates that it is a very fast reaction, as it is completed within 10 seconds. The second part suggests an incomplete reaction because, if the reaction is complete, the volume should have decreased. Therefore, the answer might be B. However, there is a problem with the question. The given conditions describe an open system, and an open system cannot reach equilibrium because products are continuously being removed. Therefore, I suspect that there might be an issue with the question, and the answer might need correction. In a revised answer, A could also be acceptable. This question assesses the role of a catalyst. A catalyst cannot change the reaction enthalpy but lowers the activation energy. Without a catalyst, the reaction enthalpy is +10, and the activation energy is +50. A reaction enthalpy of +10 means that the potential energy of the products is 10 units higher than that of the reactants. Therefore, options B and D are ruled out. Only options A and C proceeded to the next round of consideration. For option A, the highest potential energy is 60, and its activation energy is 60 minus 10 equals 50, which did not meet the requirement of a catalyst environment where the activation energy should be less than 50. For option C, the highest potential energy is only 40, and its activation energy was 40 minus 20 equals 30, which is less than 50 and complies with the catalyst environment. Therefore, the correct answer is C. This question is about the Maxwell-Boltzmann distribution curve, which represents the relationship between the number of gas particles and their energy at a specific temperature. The vertical axis represents the number of particles, while the horizontal axis represents the particle energy. The area under the curve represents the total number of particles. A single Maxwell-Boltzmann distribution curve represents only one temperature. Therefore, option A is the correct answer. Options B, C, and D have no relevance to the Maxwell-Boltzmann distribution curve. This question examines the change in equilibrium constants after a transformation of equations. First, equation 2 is the reverse of equation 1, with the reactants and products exchanged. Therefore, the equilibrium constant K2 for equation 2 should be the reciprocal of the equilibrium constant K1 for equation 1. Since the coefficients of equation 2 are 3 times that of equation 1, the reciprocal should be raised to the power of 3. Therefore, the correct answer is C. This question is about percentage yield. The actual yield of the product is provided, and you need to calculate the theoretical yield based on the stoichiometric equation. Then, by dividing the actual yield by the theoretical yield, you can obtain the answer, which is D. This question is about determining the direction of a chemical equilibrium. The given reaction has two key points. The volume terms of reactants, 3 equals 2 SO2 plus O2, are greater than the volume term of the product, 2 SO3, and it is an exothermic reaction, delta H is negative. Increasing the temperature should decrease the equilibrium constant and the yield of SO3. The first statement incorrectly suggests that increasing the temperature can increase the yield of SO3, so the first statement is false. Increasing the volume means the concentration of reactants decreases, leading to a decrease in reaction rate. Additionally, with an increase in volume, the equilibrium shifts towards the side with more moles, in this case, towards the reactants, resulting in a decrease in the yield of SO3. Therefore, the second statement is correct. Nitrogen gas did not participate in the reaction. Although injecting nitrogen gas can increase the system's pressure, the concentrations of reactants and products did not change. Therefore, injecting nitrogen gas does not affect a chemical reaction that has already reached equilibrium. Hence, the third statement is false. A catalyst did not affect the equilibrium constant, so the fourth statement was correct. Therefore, option C was the correct choice. This question provides the masses of ethanol and water as well as the temperature increase. The key is to determine whether ethanol or octane is involved in the reaction. The third statement was always true because there is always energy lost during heating. Firstly, calculate the energy released by 100% ethanol and the energy absorbed by water. If the energy released by 100% ethanol is less than the energy absorbed by water, then octane might have been mixed with ethanol, as octane has a higher combustion value than ethanol. By calculation, if the energy released by ethanol is less than the energy absorbed by water, the first option is not valid, eliminating A and C. Therefore, the correct answer is D. If the energy released by ethanol is greater than the energy absorbed by water, further analysis is needed to calculate the energy released by a 10% ethanol mixture and compare it with the energy absorbed by water. This question simultaneously assesses knowledge of chemical equilibrium and reaction rates. Key points to note are the differences between the two systems. In System X, the mole number of CH4G is 2, while in System Y, it was 1. All other conditions are the same. Therefore, the CH4 concentration in System X is greater than in System Y. Due to the higher CH4 concentration in System X, the initial rate in System X is greater than in System Y. Therefore, option A is ruled out. Because the CH4 concentration in System X is higher than in System Y, the consumption of H2O must be higher in System X. Hence, option B is correct. Since the initial conditions for the two systems are different, the rates of the two reverse reactions are also different when reaching equilibrium. Therefore, option C is not correct. This reaction is incomplete, so the proportions of reactants and products cannot be determined simply from the chemical equation. Therefore, option D is not correct. If you need my help, please add me on WeChat and WhatsApp by scanning the QR code. You can also reach me directly via email. Follow Dr. Lou's VCE Physics, Chemistry, and Biology channel on YouTube. Finally, I wish all students success.